Are you interested in boosting your career in artificial intelligence? The hot new field of generative AI is exploding, and the OCI Generative AI Professional Certificate can validate your skills and open doors to exciting opportunities. Hi everyone, Geeta here from World with Preet. I have created a video which will describe you how to register for this OCI Generative exam, and the link is shared in the description below. For developers, earning this certification showcase your skill to potential employers and sets you apart in the job market. For student and job seeker, this is a fantastic opportunity to expand your knowledge and boost your employability in booming field of AI. But with the wealth of information to learn, studying can feel overwhelming. That's where we come in. I have created this video with multi-choice questions just like the ones you will encounter on your actual exam. We will break down the key concepts, provide clear explanation, and help you understand exactly what each answer choice means. By the end of this video, you will be feeling confident and prepared to ace your generative AI certification. Let's get started. You are working on improving the security of an LLM against prompt injection jailbreaking. Which of the following scenario is most likely an example of prompt injection jailbreaking? Here are the options. Let's first discuss what is prompt injection jailbreaking and what does it aims. So basically, prompt injection jailbreaking aims to bypass the LLM's built-in safeguards and force it to perform actions it would not normally do, right? So based on this understanding, let's try to read each of this statement and we will try to focus which statement is closer to the prompt injection jailbreaking. The first option is a researcher provide the LLM with a prompt that asks it to write a poem while including factual information about the history of poetry. This additional information helps the LLM to generate a more informative poem. So if you read this statement, this is the normal way how we are using the prompting. The additional information helps the LLM to generate a more relevant and informative response, right? So this is not the choice for prompt injection jailbreaking. Now let's see the option number B. A user prompts the LLM to write a news article but modifies the prompt to instruct the LLM to ignore all claims of political bias, even if they are supported by evidence. This is a correct choice. Why? Because here you are asking the prompts to write a news article, but at the same time you are instructing him to ignore some of the instructions like claims of political bias, which is not fair. So this option looks quite correct. So let's park this option as a correct choice, but still we will focus on point number C and point number D. Now point number C is a developer trains the LLM on a dataset that includes various writing styles and format. This allows the LLM to adapt its writing style to different prompts. Training the LLM on diverse data helps it to adapt to different style, right? But it does not bypass any safeguards. So this option is also not the right choice for prompt injection jailbreaking. Now option number D is a student asks the LLM to write a summary of scientific paper but adds a sentence to the prompt questioning the validity of paper's conclusion. This additional sentence helps the LLM identify potential biases in the research. Now, if you see the option number D, while adding a critical question might influence the summary, it does not directly instruct the LLM to ignore factual information or bypass safety features, right? So that's why this option is also not the right choice. So it is most likely the example of prompt injection jailbreaking, which is the option number B, because it modifies the prompt to force the LLM to ignore potentially factual information about the political bias, even if it is supported by evidence. So this manipulation attempts to control the LLM's output in the way that bypasses its usual fact checking and bias detection mechanism. So I hope this will clarify you why the option B is the correct choice. In OCI Generative AI, what does a K-short prompt refers to when used for text generation tasks? And here are the choices. Okay, if you read the question carefully, here the main focus is on K-short learning and the prompt-based generation, right? So let's discuss about these things. What is K-short learning? This is a machine learning techniques where the model is trained on a small set of K examples or shots before performing a task. And if you think of the prompt based generation, OCI generative AI models often rely on prompts to guide the text generation, right? So if we combine both of these sentences, K short prompt in text generation. In this context, K refers to the number of concise prompt provided. Each prompt can specify a desired style, tone, content area, or other aspect to influence the generated text. Now let's discuss each of these points. The first point is a single prompt example provided to guide the model's text generation with k is equal to 1. Now here the focus is on single prompt. While a single prompt can be used, k-short prompt specifically involve providing multiple prompts, right? So that's why this options looks less similar to what the question is asked for. Now the next statement is a series of key concise prompt, each guiding the model towards a specific style or content direction. This is the most accurate answer, right? As it is completely involving some of the parameters like case, concise prompts, and the prompt based generation, and also specific styles and the directions what we have discussed. So let's keep this question quite closer to the answer, but still we will see the option number C and option number D. Now the option number C is a prompt containing exactly keywords that the generated text should incorporate. So here this statement is focusing on the word count. K-short prompt don't dictate the exact word count of generated text, they focus on guiding the overall direction. So that's why this option is not the correct choice. Now let's see the option number D, a prompt informing the model that it should generate k different creative text format, for example poems and the code snippets. So here the focus is on creative format. While K-short prompt might influence the style, they typically don't determine the specific creative, for example, like poem or code snippet in the OCI generative AI options, right? AI. So this is a altogether separate functionality. So that's why this option is also not quite closer, and the closer option is option number B, where a series of K concise prompt each will guide the model towards a specific styles or content direction. I hope this will clear you why the option B is the correct choice. What is the characteristics of TFU fine tuning for a large language models? And here are the options. The correct characteristics of TFU fine tuning for LLM is option number B. It selectively updates only a fraction of weights to reduce the number of parameters. And now let's try to see why other options are not right. The first option is it updates all weight uniformly. This is similar to the standard fine tuning which TFU aims to improve upon being more efficient. Then the option number C, it reduces computational load and avoid overfitting. While true, reducing the number of parameters primarily goal of TFU, even though it can be beneficial side effect. So it can lead to both reduced computational load and potentially less overfitting. But here it is saying, however, reducing overfitting is not the primary goal of TFU, even though it is a beneficial side effect. This is partly true, but the option number B is more closer. Now let's see the option number D. This is actually designed to be faster than traditional fine-tuning because it updates only few parameters, while it says it increases the training time. That is not correct. It will reduce the training time. Now let's try to understand little more about TFU fine-tuning. TFU is a parameter efficient fine-tuning technique that addresses the computational cost and data requirement associated with standard fine-tuning of large language models. So it will have a selectively weight updates, and it has some benefits like it will reduce the training time, it will lower the data needs, and it will improve the efficiency. Which statement is true about fine tuning and parameter efficient fine tuning? And here are the options. Let's try to understand first what is fine tuning and PEFT technique. So in fine tuning, it will train all or most of the parameters of the pre-trained model on the new task data, and more computationally expensive due to the large number of parameters being updated. Many requirements require more training data for good performance, and that can also suffer from catastrophic forgetting, where the model forgets what it learned during the pre-training. While in case of PEFT, which is parameter efficient, it focuses on updating a small subsets of parameters, typically in the final layers closer to the output, so less computationally expensive compared to the fine tuning, and also it required less training data due to leveraging the pre-trained knowledge, and that's why it is less prone to catastrophic forgetting. The option number A is fine tuning and PEFT do not involve model modification. They differ only in the type of data used for training, with fine tuning required labeled data and PEFT using unlabeled data. So the option number A is not correct because fine tuning and PEFT both require same type of data, that is the labeled data. Now the option number B is both fine-tuning and PEFT require the model to be trained from scratch on new data, making them equally data and computationally intensive. This statement is not correct because neither method require training from the scratch. They leverage on a pre-trained model and adapt it to a new task. However, fine-tuning can be computationally expensive due to training of all the parameters. So this also makes this statement wrong. Then the third one is PEFT requires replacing the entire model architecture with a new one designed specifically for new tasks, making it significantly more data intensive than fine tuning. So this is also not correct. PEFT does not require replacing the entire architecture. It uses the existing architecture but updates a specific sets of parameters to learn this new task. So that's why this statement is not correct. So the only option left now is D. But let's try to evaluate this as well. Fine-tuning requires training the entire model on new data, often leading to substantial computational cost, whereas PEFT involves updating only small subsets of parameters, minimizing computational requirement and data models. So that's completely right. Fine-tuning requires all parameters, while PEFT is focused on small subsets of parameters. So this makes this statement true. So the option number D is right. You are using Oracle Generative AI to write a creative story prompt. While you want the story to be surprising and interesting, you also want it to remain coherent and relevant to the prompt. How can you use top key and top P settings to achieve this balance? And here are the options. For this thing, answer number B is the correct choice. Setting top K to a low value with few possible next words and top P to the high value, encouraging exploration of less probable words, will be the right choice. Now let's try to explain it in more detail way. What is top key? This parameter controls the number of most probable words considered for the next step in the generation. A higher top K value allows for more choices, potentially leading to more diverse and surprisingly output. However, it can also increase the chance of incoherent or irrelevant words being chosen. And now let's see what is top P. This parameter controls the probability distribution from which the next word is chosen. A higher top P value encourages exploration of less probable words within the top K selection, promoting creativity and unexpected turn in the story. So for a creative story prompt, you want to strike a balance between coherence, which ensures the story makes sense and stay relevant to the prompt, and also surprise, introducing unexpected elements to keep the story engaging. By setting top K to low value, you limit the number of possible next words, helping to maintain a consistent flow and reduce the chance of nonsensical choices. At the same time, setting top P to high value encourages the model to explore less probable words within those choices, allowing for creative and interesting direction in the story. This combination allows for some exploration while prioritizing a generally coherent and narrative. Now let's try to focus on another sentences also why we feel this is not correct. So the option A was high top K can lead to incoherence, while low top P it will reduces the exploration too much. So that's why this option is not correct. Option number C, where both the high values can result in confusing a mix of very probable and very improbable words, potentially hindering both the coherence and surprisingly. So that's why this option is also not right. And the last one was low top key and low top key settings, right? This limits the exploration and creativity, leading to predictable and potentially repetitive outputs. So that's why the option B is a perfect choice where we can use top K with low value and top P with the high value. What is the purpose of RAG in text generation? Here are the options. Now let's understand RAG. What is RAG? RAG addresses a limitation of LLMs, their static knowledge base. They can struggle with factual accuracy or keeping up with real-world information updates. So RAG bridges this gap by retrieving relevant information. So given a user prompt or input, RAG utilizes a retrieval model to search an external data source, for example Wikipedia, for relevant documents or passages. Then it will contextualize the retrieved information. The retrieved information is presented to LLM alongside the user prompt. This helps the LLM understand the context and generate text that aligns with both the prompt and the retrieved data. The next one is enhanced text generation. By incorporating this external knowledge, RAG aims to produce more informative, factually accurate, and up-to-date text compared to LLM rely solely on their internal knowledge. Now we will also see some of the benefits of RAG. So as we discussed, it will help in improving the factual accuracy, it will help in enhancing the contextual understanding, and also it will help in adaptability to evolve the informations. And the correct answer is to generate text using extra information obtained from an external data source. Now let's discuss why other options are not correct. To generate text based only on the model's internal knowledge without external data. This is opposite of what RAG aims to achieve. It leverages external information to enhance the generation. The next option was to store text in an external database without using it for generation. RAG does not just store the information, it retrieves and uses it for the text generation. So that's why this option is also not correct. The next one is to retrieve text from an external source and present it without any modification. While RAG retrieves the information, it does not simply copy it. It uses the retrieved data along with the user prompt to generate the new text. So that's why this option is also not correct. When using top P in generative AI model, how does it determine which token to select for the next step in the sequence? And here are the options. Here, read the question carefully, what it is asking for top P parameters, right? So let's discuss on that. First, let's understand how top P parameter works. So top P does not directly pick the single most probable word or choose randomly. Instead, it focuses on subset of high probability tokens and it uses a cumulative probability approach. So there are 5 categories. For example, the first one is probability distribution. The model assigns a probability score to each possible token word for the next step. Descending order. The tokens are arranged in the descending order based on their individual probabilities. Cumulative probability. The model starts adding up the probability of this token beginning with the most probable one. And the fourth one is threshold reach. So once the cumulative probability reaches or exceeds with the chosen top p value, for example let's say 0.7, the selection process stops. And the point number 5 is random choice within the threshold. So from the remaining tokens, those whose cumulative probability falls within the top p threshold, the model randomly picks one of them for the next step in the sequence. This approach ensures that the generated text prioritizes high probability words while still allowing for some exploration for less probable but potentially increasing these options. Now, based on this understanding, let's try to explore each of the options mentioned. The first is top P directly picks the word with highest individual probability. So this option is not correct because top P considers a set of high probability token, not just the single highest one. Then the option number B, top P selects a random word from all possible tokens. So this statement also is not correct as top P utilizes probabilities, not random selections from all possibilities. Then the option number C is top P chooses a word based on its position within the sentence structure. So this also is not a correct statement. Top P focuses on probability, not word order with the sentence structure. That's why now only option D is remaining. Top P consider the cumulative probability of the most likely tokens until it surpasses the chosen threshold. So this will completely fit here. What happens if a period is used as a stop sequence in the text generation? And here are the choices. What is a stop sequence? Stop sequence is a strings which tells model to stop generating more content. And here are the choices. The first is the model stop generating text after it reaches the end of current paragraph. So the option number A is focusing on end of paragraph. While periods often mark the end of sentences, they can also appear within the paragraph. A model solely rely on the periods for stopping might end perpetually within the paragraph. So that's why this is not the correct choice, right? It can stop after one sentence as well. Now the option number B is the model ignores the period and continues generating text until it reaches the token limit. So here the focus is on ignoring the periods. This is a more common behavior in text generation model. They might prioritize reaching the token limit and ignore the periods to ensure a more coherent overall output. But this is not the correct choice, right? Because here the question itself is asking about the dot operator or a period sign. So that's why this is not the correct choice. Now let's see the point number C. The model stops generating text after it reaches the end of first sentence even if the token limit is much higher. So here the focus is on stop sequence purpose. A stop sequence is a signal that tells model to halt the text generation using a dot as a stop sequence. would ideally instruct the model to stop when it encounters a period. And the second option is strict interpretation. If the model is trained to strictly interpret period as a stop sequence, it will terminate generation at the end of first sentence regardless of the remaining token limit. So that's why based on this understanding, both of these options looks quite correct. So here the option number C is the correct choice because it should encounter at the end of first sentence, and also it will not bother about the token limit, how much token limit is configured. So that's why the option C looks quite correct. But still, let's discuss about the point number D. The point number D is the model generates additional sentences to complete the paragraph. Now here the focus is on completing the paragraph. While some model might try to complete a paragraph when encountering a dot, this would not be guaranteed behavior, specifically with the strict stop sequence setting. So that's why this option is also not the right choice. So the correct answer is option number C. What is LCEL in the context of LangChain chains? And here are the options. LangChains allow you to build application powered by LLMs. This application often involve multiple LLM components working together in a sequence, while LangChain expression language provides a concise and readable way to define this sequence, specifying how the output from one component becomes the input for the next. And the correct answer is a declarative way to compose chains together using LangChain expression language. Here's why. Let's see now why other options are not correct. The another option is a programming language used to write documentation for LangChain. LCEL is not a separate programming language for documentation. LangChain likely has its own documentation for it, and LCEL focuses on composing the logic within chains. The next option is an older Python library for building large language models. LCEL is not a library for building LLMs, it's a way to define how different LLM components interact within a LangChain workflow. And the next option was a legacy method for creating chains in LangChain. While LCEL might be a established way of composing chains, it's not necessarily considered as a legacy method. It's a prominent approach within the LangChain framework. What does temperature parameter in generative models define? Here are the options. The first option is temperature is used to control the output of generation model. Temperature determines the maximum length of generated text. Temperature is responsible for selecting the most likely token during the text generation, or the temperature adjusts the learning rate during the model training. Now let's try to understand each statement. The first statement says temperature determines the maximum length of generated text. This is typically controlled by a separate parameter or stopping criteria. Temperature deals with choice, not the overall length. Then the next one is temperature is responsible for selecting the most likely tokens during the text generation. Not entirely true. Temperature influences the selection process, but it can choose less likely token with a high temperature for exploration. It balances choosing the most likely option with exploring less probable but potentially increasing ones. And the another one is temperature adjusts the learning rate during the model training. Temperature is used during the generation, not during the training phase. Learning rate is a hyperparameter that controls how quickly the model updates its weight during the training. So the correct answer is option number A, where temperature is used to control the output of generation model. What is prompt engineering in context of large language models? Here are the options. Now let's try to understand each of these statements. Training the model on a large data set. This is a core process of training LLMs, but prompt engineering happens after training. Then the next one is adjusting the hyperparameters of the model. While hyperparameter tuning can improve the LLM performance, it's not same as prompt engineering, which focuses on crafting specific instruction, adding more layer to the neural networks. This is a more structural change to the model itself, not something done during the prompt engineering. So the remaining action is option number D, which is the correct choice. The prompt engineering refers to iterating, refining the ask to elect a desired response. What does the loss matrix indicate about a model's prediction? Here are the options. As per the definition of loss matrix, loss is a measure that indicates how wrong the model's predictions are. So accordingly, option B is the correct choice. But let's try to evaluate other statements as well. The first indicate says loss indicates how good a prediction is, and it should increase as the model improves. This is possible of how loss works. A lower value indicates better model performance, that is less wrong predictions. Loss measure the total number of predictions made by a model. This is not the function of loss. It focuses on the quality of predictions, not the quantity. And another one is loss describe the accuracy of right prediction rather than the incorrect ones. Accuracy is a separate matrix that measures the percentage of correct predictions. Loss directly addresses the errors, which are incorrect predictions. So that's why the option number B is the correct choice. In the context of generating text with a LLM, what does the process of grading decoding means? And here are the options. Now let's try to evaluate each and every word. The first option is choosing the word with highest probability at each step of decoding. Grading decoding makes a deterministic choice based on the highest probability. So this option looks correct. Now let's try to still explore other three options. The second option is selecting a random word from the entire vocabulary at each step. This approach would not lead to coherent text. Random selections ignore the context and relationships between words. The next option is picking a word based on its position in a sentence structure. While word order is important, greedy decoding considers the probability of the text of next word given with the current context, not just its position. So this also does not fit. Then the next one is using a weighted random selection based on a modulated distribution. This concept is related to other decoding methods like sampling, but not specifically grading decoding. So accordingly, with all this statement, the option number A fits better because grading decoding makes a deterministic choice based on the highest probability. Which statement is true about string prompt templates and their capability regarding variables? And here are the options. String prompt templates are designed to be flexible and allow for the inclusion of 0 or more variables. That's why other options are wrong and the option B is the correct choice, which is they support any number of variables including the possibility of having one. Now let's try to little more evaluate other statements. The first option is they can only support a single variable at a time. While some parameter might be limited to a single variable, many can handle multiple variables too. They require a minimum number of two variables to function properly. This is also not a general requirement. Template can be informative and functional even without variables. Now the next one is they are unable to use any variables. This would severely limit their usefulness. Variables allow for customization and adaptation to different situations. So that's why the option number B is the correct choice, which fits completely regarding to the definition of string prompt templates. They support any number of variables including the possibilities of having none. An LLM gives intermediate reasoning steps as part of its responses. This one is true for which of the below sentences? The correct answer is chain of thought. Chain of thought is a specific technique in LLM prompting where the model is encouraged to explicitly show its reasoning steps while arriving at the final answer. Now let's discuss some of the other things why they are not correct. In context learning, on the other way, it refers the LLM's ability to learn and adopt its responses based on the specific context of a prompt or conversation. Step back prompting. This technique involves providing the LLM with additional prompt or instructing after it generates an initial response. You can consider this for generating some complex algorithms of physics and chemistry. Leads to most prompting. This is a technique or we can say a prompting strategy where you start with very broad prompts and gradually refine them to get more specific outputs. This is more like divide and break policy. So first you divide the task and then you can continue to integrate this task together. So this is how it works, leads to most prompting. Based on the concepts of chain of thought, leads to most and step back, here are the examples given. You have to find out which sequence is correct. So here is the set of questions. Pause for a while and read the questions carefully. As this example relates to different techniques, first try to at high level understand what is chain of thought, step back and leads to most technique. So chain of thought, in this technique, this will be useful to explicitly state the reasoning behind each steps, while leads to most will break down the problem into smaller steps, and step back is crucial for complex problems like chemistry and physics and so on, right? So now understand from the scenario analysis perspective. The first question is related to the counting footballs, right? So if you see here, we think from the chain of thought perspective. It allows LLM to explain its thought process, stating something like first identify the number of cans 5, then multiply it by number of footballs per can, let's say 10, and to find the total number of footballs in the cans, right? Finally, add this number to the Ritvik's initial football to get the final total. So here some intermediate steps are required. So I feel chain of thought is the quite closer to this example. Now let's discuss about the step back approach. So for step back, if you consider, this is looking like a straightforward problem. There is no complexity found out in this problem. However, it could provide some context by summarizing the task as calculating the total number of football after considering the additional cans, right? But this is not that complex. So I think step back is not the accurate match, but chain of thought is more closer. While least to most will focus on dividing the problem and then solving the small steps, right? So seemingly, if we consider this thing, LLM explicitly states its reasoning through chain of thought can be the more valuable than just performing the calculations directly. Here the direct calculations are not given, right? Like if this is the case, do the direct calculation. In that case, least to most will be the better approach. So for the question number 1, chain of thought suits better out of these three techniques. Now let's discuss about concatenating names. So if we see here, the concatenation is like take the last letter for each word and concatenate it, right? So chain of thought, if we consider here, it explains more from the reasonings, but here there is no more reasoning is required. Like you have to just find the last letter of each name, x is the final character in string, and then combine this last letter a to form the output, right? This is how the chain of thought will think. And how the step back will think for this one, like summarize the task as combining the last letters of these names to form a single string. While least to most, how it will consider, it will just outline the reasoning through chain of thought cannot be more beneficial here, right? As the statements are quite straightforward. So here I feel dividing each things one later and getting is more accurate approach, and here least to most will be a better choice compared to other two. And now let's consider the third question. So for the third question, it is focusing on ideal gas law, which is related to some physics or chemistry. If any laws are needs to be considered, the first thing comes in our mind is related to step backs, because the step back is related to all the physics and chemistry problem solving, right? But before still going to the conclusion, let's try to understand from the three techniques how they will be reading these instructions. So if we see chain of thought, it could have explained like first identify the relevant gas laws like Boyle's law, Charles' law that relate pressure, temperature and volume. Then apply the law considering the given factor for temperature and volume change. And finally combine the result to determine the overall impact on the pressure. So this is how the chain of thought could have think from. And if we consider for the step back, it could have asked to summarize like this task require applying gas law to predict how changes in temperature and volume affect the pressure of ideal gas. So this is what is quite accurate here. And least to most, similar to other scenarios, LLM could have used this internally, explaining the reasoning behind each step through chain of tasks taking the priority. So ideally here chain of thoughts and least to most are less relevant, and step back is a quite closer, right? So I hope now we have a good understanding of each of these questions, and we have tried to categorize all the three techniques in each of these questions, and we have tried to get some conclusions, right? So if we consider all this thing, now go back again to the question and we will try to see which options are closer. So for the first option is chain of thought, step back, least to most. So this is not correct. As per our understanding, the first scenario is well fitted for chain of thought, second is for least to most, and third one is for step back. So if we see these questions and statement carefully, option number 2 is having the same steps: chain of thought, least to most and step back. So this is the correct choice. C and D related to first, least to most and step back. So this two completely go off because the first is for chain of thought. So A and B are the options needs to look into, but again evaluating the scenario 2 and scenario 3, this is the more accurate with option number B. So our answer is option number B, chain of thought, least to most and step back techniques. Which of the following methods is best suited to compare the directional similarity between two numerical vectors regardless of their magnitudes? Here are the options. The first option is Euclidean distance, Manhattan distance, cosine similarity, and the dot product. Before understanding what the correct answer is, let's try to understand what are these things. So the first one is Euclidean distance and Manhattan distance. These are the distance matrices that cover both the direction and magnitude of vectors. While they can be useful for finding the closest point in space, they are not ideal for measuring purely directional similarities. Dot product, while related to cosine similarity, directly multiplies the corresponding elements of vectors and sum the results. This incorporates both direction and magnitude, making it less suitable for tasks where magnitude does not matter. Cosine similarity, on the other hand, it normalizes the dot product by dividing the product of vectors' magnitude. This effectively eliminates the influence of magnitude and focuses solely on the angle between vectors, making it optimal choice for comparing directional similarity. So the correct answer is option number C, that is cosine similarity. You are creating a fine-tuning dedicated AI cluster to customize a foundational model with your custom training data. how many unit hours are required for fine tuning if the cluster is active for 10 hours. And here are the options. If you read this statement carefully, here are some of the things we need to consider. For example, fine tuning, right? So for fine tuning dedicated AI cluster model, this is specifically designed with custom data. So it will use the 2 unit as a information, right? So if we will consider this thing, it requires 2 units and we need total this for 10 hours. So 2 multiplied by 10 is equal to 20. So the correct answer is 20. In Oracle Generative AI models, what does the likelihood parameter present? If you read the question carefully, it is asking for likelihood parameter. So pause for a while and let's see what are the options available here. The likelihood parameter in Oracle Generative AI model represents the probability assigned to each possible token that could follow the current token in sequence. Higher number indicates a greater likelihood of a specific token appearing next. This information is very crucial for model during text generation. And the model considers the likelihoods of all possible tokens and chooses the one that best fits the context and maximizes the overall probability of generated sequence. Now let's see all of the statements. The first statement is token with higher numbers are more likely to follow the current token. So this is a true statement as we discussed. Now let's see another statements why they are not correct. While the training data might influence the token probability, likelihood refers to the model interference representation of these probabilities, not simply the frequency in the data. That's why the option B is not correct. And for option C, while confidence can be related to the highest likelihoods, likelihood represents the probability for all possible next token, not just the most confident choice. So that's why this option is also not correct. And then fourth option was text length is typically controlled by separate parameters like maximum sequence length. Likelihood focus on the word probabilities within a sequence. So that's why this option also is not correct. When fine-tuning custom machine learning models, where should you store the training data set to ensure both security and accessibility? If you read this question carefully, here some of the key terms are fine-tuning custom models, right? So this is the important thing. So it is talking about the fine-tuning custom model where it can be stored during the training data set, right? And this is more specifically from the security and accessibility perspective. So here are the choices. So training datasets for fine-tuning custom models often contain sensitive information depending on the specific task. Here's why the object storage with encryption is the best choice for storing this dataset. Now let's consider first the object storage. So cloud object storage is a scalable and cost-effective solution for storing large datasets like training data. It allows you to easily manage and access the data for training purposes. And another important term here is encrypted format. Encrypting the data at rest within the object storage buckets add a crucial layer of security. And this protects the data from unauthorized access even if some manages to gain access to the storage itself. So if you read the statement, it is looking for both the security and accessibility. So the combination of these two will help us in giving the more fine-tuning training data set the sensitive information caring. And that's why the option number 1 object storage buckets in encrypted format is right. But now let's consider another options as well, why we feel that these are correct or not correct, right? So the another option is data lake services. While some cloud platforms offer data lake services that centralize data storage and management, object storage remains a widely used and reliable option specifically for training the datasets. Then the next one, if you see from the security perspective, it's essential to choose a cloud storage provider with the robust security features including encryption options and access control. So depending on the nature of your training data, there might be data privacy regulation to consider. Encryptions helps to ensure the compilation with such regulations. Here's why the other optionals are not ideal. So if you consider like data leak services, that are a viable option, but for security reasons, training data should be stored in encrypted format. So that's why this option can be eliminated. Then the next one is key management service. Key management service is crucial for managing the encryption keys used to access and decrypt data stored in object storage bucket or other encrypted location. However, it's not the primary location for storing the data itself, right? So that's why this option is also not correct. And not all cloud storage locations offer robust security features like encryption. For sensitive training datasets, object storage with encryption is the recommended approach. I hope this will give you the clear idea about this question. What is odd one out in providing the choices in generative AI? And here are the options. If you read this question carefully, its focus is on memory. All the options like conversational summary memory, conversational buffer memory, conversational all image memory refer to different types of memory used in the conversation within the OCI generative AI, right? And another thing, if we consider, that is focus on the token. So conversational buffer token memory, it seems like a combination of two existing terms, conversational buffer memory and token memory, right? So while token might play a role in conversational processing, it's less likely to be a specific memory type compared to others. So accordingly, if we see this option's conversational buffer token memory looks odd, but let's still try to understand more. So for example, if we consider conversational summary memory, this refers to the memory that stores the summary of past conversation, which can be helpful for maintaining context during the ongoing interactions, right? So this looks more from the summary perspective. The another one is conversational buffer memory. This could be the memory that holds the actual conversation buffer, storing the recent back and forth exchange between the user and AI system. And conversational image memory, this might be the memory dedicated to store and reference image used within the conversation, potentially for the task like image description or retrieval based on the conversational context, right? So at conclusion, only the conversational buffer token memory seems like the less specific memory type compared to other formats, because they other are focusing on the conversations like summaries, buffer or another image related thing, but nobody is talking about the combination of token and memory, right? So that's why this options goes out. In Oracle Generative AI, which one is the odd one? Summarization model, generation model, embedding model, or the translation model? If you read the question carefully, we will have discussed about generation model, summarization model, and embedding model in the entire course, right? And we have also seen how we are using different coherent commands, light commands, and other things while configuring the generation model, summarization model, and the embedding model. And also in this course, we have seen about the different types of parameters which can help us during the token generation as well, right? So accordingly we have given quite information related to these three models, but for translation model we have not seen any of the information related, right? So this one is looking completely the odd one out. And if we consider from the definitions perspective, generation model conforms the functionality for creating new text context, and the summarization model, it is focusing on fine tuning for the summarization of task. Embedding model conform the functionality for creating numerical representations of the text, while transformation model, it is more specific for translating text from one language to another. So this one we have seen during the encoding decoding, right? So this one is not any specific model available as such in the OCI generative model, but we are using the translation functionalities, right? So this option is the odd one. Our next question is, what is model endpoint? And here are the options. A dedicated AI cluster where a LLM can accept user requests and send back the user responses. Or it's a software program that trains LLM on massive data sets. Or it's a web interface for interacting with and visualizing the output of LLM. Or option number T, a stable and durable URL that allows you applications to access and interact with the trained LLMs, right? So let's discuss. A dedicated AI cluster can house the LLM and the necessary resources like processing power and memory to handle user requests in real time. The endpoint with the cluster act as the entry point for user requests and send response back through the same endpoint. So this is a common deployment approach for large language model. So accordingly, the option A looks correct choice. And if we consider the option number B, a software program that trains LLM on massive data sets, right? So for this thing, model training is a separate phase, but the trained model is often deployed within a dedicated AI cluster accessible through the model endpoint, right? So this is not related to the endpoint definition. The third one is a web interface for interacting with and visualizing the output of a large language model. A platform for deploying and managing large language model might encompass functionalities like model endpoints, but it's a broader concept. So that's why this also does not be the right options. Now the option number D is a stable and durable URL that allows application to access and interact with a trained large language model, right? This describes some aspects of model endpoint. It does not fully capture the functionality in the context of large language model. That's why this option is quite closer, but this is not the correct one. And the correct option is option number A. It's important to note that the model endpoints can exist in different configuration depending on the specific platform or the cloud service used, right? So if you consider from this perspective, there are two approaches. One is the cloud based endpoint and another is the on-premises endpoints. In cloud-based endpoints, the cloud platforms like OCI offer managed services for deploying large language models. These services often involve creating a model endpoint as part of the deployment process. While in case of on-premises endpoints, for on-premises deployments, the dedicated AI cluster and associated model endpoint might be managed by the organization itself. Okay, so in conclusion, option D looks quite closer, which is describing more from the features perspective, but the actual choice is option number A because the end model represents the interactions between the user request and sending back the response. Okay, so that's why the option A is the right option here. Which is a distinctive feature of GPUs in dedicated AI cluster used for generative AI tasks. And here are the options. So if you see here, this statement is asking about the GPUs, right? So let's focus on the dedicated AI clusters and the GPUs. In dedicated AI cluster for generative AI, it's crucial to isolate the GPU allocated to a customer's task. This isolation offers several benefits like security. It prevents unauthorized access to the customer's data and model running on the GPUs. And from the performance perspective, it ensures the customer's workload that has exclusively access to allocated resources, maximizing the performance and predictability. And this one is also important to know from the reproducibility perspective, which isolates help maintain the consistent results for customer generative AI tasks, right? So now let's read the questions again. The first option says GPUs are shared with other customers to maximize Resource utilization. While resource sharing exists in some cloud computing models, dedicated AI clusters typically provide dedicated resources, including isolated GPUs, for a specific customer workload. So that's why this option is not correct. Then each customer's GPU are connected via a public internet network for ease of access. Public internet connections are generally not used for high performance computing within a dedicated AI cluster due to the security and performance concern. Dedicated clusters usually have the internal high speed networks for communication between components. So that's why this option is also not correct choice. GPUs are used exclusively for storing large datasets, not for computations. GPUs are specifically designed for parallel processing, making them ideal for computationally intensive tasks like generative AI. While some storage might be attached to the AI cluster, the primary function of GPUs is computation. So that's why this statement is also not correct. And the correct statement is GPUs allocated for a customer's generative AI task are isolated from other GPUs. So that is a correct statement. For any of the individual customer, a specific dedicated AI cluster is given to them with the GPUs. So that's why for every customer there is a dedicated AI cluster. So with this statement, this is the perfect statement. You have an image and want to use an OCI generative AI model to analyze it and generate a textual description. Which option is most suitable model type? If you read this statement carefully, what it is giving, you have an image and you want to use an OCI AI model to analyze it and generate the text generation, right? So from image, you want to generate the text generation. And here are the choices. Now let's break down each of the options and let's decide which is correct and which is not best fitting for this statement. The first one is the diffusion model. Diffusion models are primarily used for image generation, not for image analysis and text description. So that's why this option is not the correct choice. Now the second one is RAG, Retrieval-augmented generation. While RAG can be helpful for text generation tasks, that benefit from external information retrieval, it would not be the first choice for analyzing an image and generating the description. RAG is better suited for tasks where the model can access and leverage the relevant text data alongside with its own knowledge. So let's keep it park. This also looks like not the correct choice. Now point number C. Pre-trained text encoder. Pre-trained text encoders are useful for tasks like text classification or generating text embedding. They would not directly generate a textual description from an image. So point number C is not correct. Then we will go to the point number D. Large language models. They are powerful for various tasks including image captioning. Some LLMs are pre-trained on image text datasets, allowing them to analyze images and generate the textual description. So point number D is the correct choice here. Don't get confused with point number B because point number B is more focusing from the textual information. Okay, so that is the first choice for them, and it is not the first choice for them to analyze the image and generate the description. So that's why point number D is the correct choice, that is the large language models. LangSmith in OCI can be used for, and here are the options: monitoring, debugging, evaluating, and analyzing. Let's discuss each of this point. The point number one is monitoring. LangSmith provides tools to continuously trace the health and performance of LLMs in operation. This includes monitoring metrics like accuracy, latency, and resource utilization. So these points look quite correct. Point number B is debugging. When LLM exhibit an unexpected behavior, LangSmith can help identify and diagnose the root cause of the error. This can involve tracing the execution flow, analyzing input and outputs, and pinpointing specific issues within the LLMs. Then point number C is evaluation. Evaluating the effectiveness of LLM is crucial. LangSmith offers functionalities to assess the accuracy, fairness, and overall performance of LLM on different tasks. And the fourth one is analyzing. Analyzing various aspects of LLM behavior is essential for understanding and improving their performance. LangSmith allows user to analyze LLM outputs, explore learn representations, and gain insights into the model's internal working. So that's why if we consider all of these things, the point number one, monitoring, is quite correct because it includes the importance of continuous oversight. Monitoring is crucial for ensuring the ongoing reliability and performance of LLMs in production environments. It allows you to proactively identify potential issues before they significantly impact the user's experience or results. And foundation for other functionalities. Effective debugging, evaluation, and analysis is often rely on data collected through monitoring. So all these three options are related in either way to monitoring. So that's why monitoring is a quite closer choice. It provides a baseline for understanding LLM behavior and identifying deviations that might necessitate further investigation using other LangSmith features. So while debugging, evaluation, and analysis, they are all vital aspects of managing LLMs. Monitoring acts as a foundation for proactive management and early detection of potential problems. So that's why the first option, monitoring, is quite closer and this is the correct choice. Now the next question is the most suitable option for LangSmith functionalities is detecting, evaluating, reading code accessibility, or measuring. The most suitable option here is evaluating. Let's discuss why. Focus on LLM performance. LangSmith is primarily designed to support the development, testing, and operation of LLMs. Evaluation aligns well with this focus. Evaluating various aspects. Evaluation in LangSmith can encompass different aspects of LLM performance, including accuracy, fairness, bias, and efficiency on specific tasks. Along with that, there is a complementary functionalities like while LangSmith does not directly address to the other points, it can work along with them, detecting. So evaluation might reveal unexpected behavior or errors, prompting further investigation using the debugging tools. So detecting is useful for the debugging purpose. And reading code accessibility, if we see, LangSmith does not directly focus on code accessibility, but evaluation results might highlight potential issues that could be addressed through the improved code structure or documentation, which could impact human understanding of LLM. So this option is also not correct. And then another one is measuring. Evaluation often involves measuring various performance metrics that can be used to assess the effectiveness of LLMs. This one is also one of the functionalities of LangSmith, but the very close functionality is evaluation. Evaluation is quite important here, so the correct choice is evaluation, although detecting and measuring are quite closer, but this all things can be one of the part of evaluation. So evaluation can be used for detection and for measuring. So that's why the correct choice here is option number B. Oracle ADS provides which class to assist with LLM application deployment, which makes it easy to deploy LLM application to OCI data science model deployment. And here are the options. Chain deployment, LangChain communities LLMs, LangChain's chains, or conversational buffer memory. If you read the question carefully, here the more focus is on deployment, right? So it is looking for which deployment class. LangChain community.llms and LangChain.gens, these are not used for for the deployment, but these are used for using the OCI's other functionalities for OpenAI, right? So that's why this B and C options are not correct. And conversational buffer memory is more specific requirement related to memory. So B, C, and D are very clear that they are not part of deployment. And the chain deployment is the class available in Oracle ADS, and that is the correct choice. By default, the vector store retriever uses with similarity search in the below code. So there is one functionality given, retriever is equal to db dot s underscore retriever, search type is hyphen. So which search type is used here? It is a similarity, MMR, similarity score threshold, or top key. By default, the vector store retriever uses the similarity search type in the code snippet. So the correct answer is similarity. Now, here is a breakdown of the option and why similarity is default. So let's first discuss something about similarity. This is the default search type for the vector store retriever. It retrieves documents from the vector store that are most similar based on their vector representation to query the vector. This is the most common and versatile search approach for retrieving relevant documents in a vector search setting. Now the second option is MMR. MMR means maximum marginal relevance. MMR is a search technique that aims to retrieve a diverse set of documents that are both relevant to the query and dissimilar to each other. This can be helpful if you want to avoid retrieving multiple documents that express the same idea. However, MMR is not a default choice as it requires additional configuration and might not be suitable for all scenarios. The next one is similarity score threshold. This search type retrieves documents whose similarity score to the query vector exceeds a certain threshold. This allows you to control the level of strictness in search result. While powerful for specific use cases, it's not the default because it requires setting a specific threshold value which might need adjustment depending on the dataset and task. The last one is top key. Top key itself is not a search type but rather a parameter that can be used with any of the search method mentioned above. It specifies the number of most relevant documents to retrieve. For example, if you give here retriever.search with query vector and top key equal to 10, it would retrieve the top 10 most similar documents using the default similarity search type. So in conclusion, the default search type for db.asRetriever is similarity, which retrieves the most similar document to the query based on their vector representation. What is the key difference between RAG sequence and RAG token model in retrieval augmentation generation? And here are the options. The key difference is how they utilize the retrieved documents. RAG sequence rely on a single document for entire generation, while RAG token leverage multiple documents in a more selective manner. So now let's see which option is matching quite closer. The option number A is RAG sequence uses the same retrieved document to generate the entire output sequence. So this statement is quite correct as I discussed, right? Now still let's go further for another points. The point number 2 is RAG tokens. RAG token uses different documents for each word in generated text. So here the focus is on RAG token. Unlike RAG sequence, RAG token retrieve multiple documents relevant to different parts of the query. It then utilizes the document selectively using different retrieved documents for generating specific words or token in the final output sequence, which will help them to generate the more informative generation process, right? So here all of these informations are not available, so we will park the second option. Then point number C is RAG sequence require pre-training on massive data set of code, while RAG token requires pre-training on text. This is not correct. Both RAG sequence and RAG token model typically require pre-training on massive text datasets. They don't specifically require code for pre-training. So that's why this statement is not correct. Now point number D is RAG sequence is a generative model while RAG token is a retrieval model. This is also not correct. Both RAG sequence and RAG token are retrieval augmented generation model. They combine retrieval and generation functionalities, right? So that's why this is not the correct choice. Then again we will come back to point number A and point number B. In point number A, it is mentioning about RAG sequence retrieve a single document based on the user query. And then the same document is used as a primary source of information for generating the entire output sequence. So most of the keywords what we are looking are quite matching in the statement number A. Same retrieve document generate the entire output sequence. This is quite closer to what the RAG sequence do. And in point number B, it uses different documents for each word. So each word is little bit confusing here because here based on the multiple documents, multiple selections will happen and then the generation of text will be happening. So that's why comparatively the option B was looking also quite closer, but the option A is very closer, so we will go for option A. What is the role of encoding decoding in OCI generative AI? Here are the options. Before going through which of the statements are correct, let's first try to understand what is encoding and decoding. So encoding and decoding, it plays a crucial role in many generative models used within the OCI generative AI. Encoding Generative models often represent text data as a numerical vector, and during encoding, the model transforms the input text into a sequence of numbers. This allows the model to process and manipulate the text data more efficiently. And in decoding, when generating the text, the model starts with a Latin representation, that is a sequence of numbers, and uses the decoder to translate it back to the human readable text, right? So this is how we use the encoding and decoding. Now let's evaluate the options. The first one is it is used to compress and decompress large datasets for training generative models. The more focus here is on data compression. While encoding might involve some level of data compression to represent text more efficiently, compression is not the primary goal in OCI generative AI. The focus is on transforming text into a format suitable for model processing. So that's why this option is not correct. The option number B is it's the core functionality of generative models, transforming text into the numerical representation and vice versa. This is the core functionality of generative models, transforming text into the numerical representation and vice versa, right? This is the correct option because this is what is the definition of encoding and decoding. Let's still go further for option C and option D. It's not directly used in OCI generative AI. Generative model processes text directly. So here the focus is not used directly. Encoding decoding is a critical functionality for most generative models offered by OCI generative AI. It's not bypassed for direct text processing, right? So this is not the correct choice. Then the fourth one is it is used for encrypting and decrypting sensitive information before feeding it to generative models. So here the more focus is on encryption and decryption. OCI Generative AI might handle sensitive text data securely, but encoding decoding serves a different purpose. It focuses on text representation for model processing, not on the encryption. So that's why the option D is also not correct. So the more accurate answer is option number B. Which of the following statement accurately describe the application of cosine similarity and dot product in text analysis? Here are the options. If we read the question carefully, the focus is on cosine similarity and dot product while generating the text analysis, right? So let's discuss first some of the key points for cosine similarity and dot product. Cosine similarity. This metric measures the angle between two vectors. In text analysis, it is used to access the semantic similarity between two pieces of text by comparing the vector representations. Text with similar meaning will have closer angle and higher similarity values. And for dot products, this operation calculates the sum of products of corresponding elements from two vectors. In text analysis, the dot product can also be used to measure the semantic similarities, although it does not consider directly the angles between the vectors like cosine similarities. However, for normalized vectors where the vector magnitude is 1, the dot product and cosine similarity values are proportional. So if we consider some of the key points, both cosine similarity and dot product can be used for semantic similarity tasks, although cosine similarity might be more common due to its ability to account for vector magnitudes. While both have applications in text analysis, they can also be used for other types of data represented as vectors. Now let's discuss about each of the options. So the first option where the focus is cosine similarity for semantic while dot is for synthetic. So this one is not correct because both are used for semantic. The statement number B is the reverse of question number 1 where cosine is used for synthetic while dot product is used for semantic. So that's why both of these are not right. And option number C, both cosine similarity and dot product are used for synthetic data. So that also is not correct. And the option number D is both cosine similarity and dot product can be used to measure the semantic similarity between the text. So this is what we have discussed. So the option number D is the correct choice. What does the embedding model V3 in OCI Generative AI primarily evaluate for input task? Here are the options. The primary function of embedding model V3 in OCI Generative AI is to evaluate the semantic meaning and relationship between words in the input text. So here is why some understanding of understanding semantics. So what is understanding semantics? OCI Generative AI model often rely on understanding the meaning and relationship between words of various tasks like text generation, machine translation and question answering, right? And vector representation, it takes the input text and transform it into a numerical vector representation, and then this vector captures the semantic information embedded within the text. And how is the relationship between them? So by analyzing the vector representation, the model can access the relationship between words and their overall contribution to the meaning of text. This understanding of semantic relationship is crucial for various generative AI tasks, right? So I hope now we have a high level overview of what is embedding model V3 and how it is useful in getting the semantics vector representation and showing the relationship. Now let's discuss for each of the options what we have. The first option is grammatical correctness of the text. So this is not the focus of embedding V3, right? As its main focus is for creating the vector representation and understanding semantics. Then the second option is sentiment of the text. It is a positive, negative or neutral. although it will do some intent analysis, but this is not the correct option. This is somehow closer to it but not very accurate. Then the third one is semantic meaning and relationship between words in the text. So this is the more accurate option as we discuss. And the fourth one is presence of name entities, people, places, organization in the text. So this also is not the primary focus. So according to the statement given, the main closing point is the third option, option number C, semantic meaning and relationship between words in the text. How does TFU fine-tuning differ from vanilla fine-tuning in the context of large language models? Here are the options. TFU fine-tuning stands out for its ability to achieve the good performance with minimal modification to the LLM's original parameters, making it a more efficient approach, right? Now let's discuss each of these options. So first option is TFU fine-tuning requires a completely new training dataset, while vanilla fine-tuning can cause the original pre-training data. So here the focus is on training data. Both approaches can potentially leverage on the original pre-training data along with the additional task-specific data for fine-tuning. So that's why this one is not accurately matching. So we can park this one for a while because it's 50% right and 50% wrong. Now go to the option number B. TFU fine-tuning focuses on improving the LLM's factual accuracy, while vanilla fine-tuning is better for creative tasks. So here the more focus is on task focus. While fine-tuning can be tailored for a specific task, both vanilla and TFU approaches can be used for various tasks, including factual and creative ones. So ideally this one also is not actually 100% correct because both are used for both purposes. So this one also we can park it for a while. Then we will go to option number C. TFU fine-tuning updates all the LLM's weight during the training, whereas vanilla fine-tuning only updates a small subset. Here the focus is on weight updates. TFU fine-tuning specifically aims to minimize the number of weights, right? While vanilla fine-tuning updates all the weights. So this information is completely not correct. So we are quite sure that option number C is not the correct choice. Now let's go to point number D. TFU fine-tuning selectively updates a small portion of LLM weights while vanilla fine-tuning update all the weights. So this is more focusing on the weight updates. So TFU fine-tuning specifically aim to minimize the number of weight, right? So this information is completely correct. This is what is the definition of both TFU fine-tuning and vanilla fine-tuning. So option number D is completely correct. Let's come back again to the point number A and point number B. So point number A was focusing on completely new training data set. So that was not correct because it also depends on some pre-training data. So we can then mark option A also wrong. And again come back to point number B. Point number B, here the focus for TFU is on factual accuracy while vanilla is for creative. Although both of these are used for both the purposes. So we can mark option number B also wrong. So here option number D, as per the definition, this one is the correct choice. So let's go for choosing the option number D. What is the main advantage of using a service with a dedicated AI cluster and single tenant GPU deployment for custom models? Here are the options. The single tenant GPU deployment in a dedicated AI cluster ensure your custom models have complete access to the processing power of GPUs, which will lead to improve the performance compared to the shared resources. Okay, so now let's discuss each of this point. The first point focuses on the service offer pre-trained model specifically designed for your custom task. So the focus is here on pre-trained model. While the dedicated cluster focus on running your own custom model, not the pre-trained models offered by the service. So this statement is completely wrong. Then we will go to the option number B. The service automatically scales the number of GPUs allocated to your workload. Here the focus is on automatic scaling. While some services might offer automatic scaling, the passage highlights the single tenant deployment, which suggests dedicated resources rather than the dynamic scaling, right? So this option also is not correctly fitting into the requirement. So we can park this also for a while. Then option number C. Your custom model have exclusively access to the GPUs in the cluster and improving the performance. So this option is the most accurate answer, because here all the three things are covered. First is dedicated AI cluster, which implies the clusters of GPU reserved specifically for your use. Point second is single tenant GPU deployment. This emphasizes that the GPU within the clusters are not shared with other users. And another is custom improvement in model. By having exclusively access to the GPU, your custom model would not have to compete with other workloads for resources. Potentially, it will help to improve the improved performance, which means faster training time and higher inference throughput, right? So this why this option is quite accurate. But before still deciding, let's go for point number D. The service provides a user-friendly interface for deploying and managing your models. So the focus here is on user interface. A user-friendly interface might be a general benefits of service, but the passage specifically points to the advantage of exclusively GPU access, right? So because of that, the option number C is the more accurate answer for this question. Why is TFU fine-tuning considered a more efficient approach compared to vanilla fine-tuning for LLMs? Here are the options. The key distinction between TFU and vanilla fine-tuning lies in the number of weights updated. TFU selectively approach leads to faster training times and lower computational cost, making it a more efficient fine-tuning methods for LLM. Now let's discuss each of this point. Option number A. TFU fine-tuning requires a smaller pre-trained model, leading to faster training. So point number A is focusing on pre-trained model size. The passage does not suggest that a TFU require a smaller pre-trained model, right? So this statement completely we cannot consider it. This is not related to the passage. Then point number B. TFU fine-tuning focuses on updating a specific part of LLM, making it more accurate. So it is focusing on updating the focus. While TFU might update a specific part, the main advantage is efficiency through the minimal weight updates, not necessarily higher accuracy. So this thing is looking quite closer. We can park this one for a while. Then option number C. TFU fine-tuning uses a completely different training algorithm compared to vanilla fine-tuning. Here the focus is on training algorithm. Both approaches likely rely on similar training algorithm, but TFU optimizes the training process by updating fewer weights. So this statement is not correct. And then the point number D is TFU fine-tuning updates a smaller portion of LLM's weights, leading to faster training and lower computational costs. This statement is completely correct. So now let's try to see why D is the most accurate answer. Fine-tuning efficiency. So the passage emphasizes the efficiency of TFU fine-tuning compared to vanilla fine-tuning. And number 2 is weighting updates. So way updates, the passage mentioned vanilla fine-tuning involves update to all the layer or most of the layer, while TFU fine-tuning updates a smaller portion. So that also is another point which is quite coming to the passage. And the third one is the computational cost. So faster training and lower cost are directly linked to the reduced number of weights update in TFU fine-tuning. So all these three keywords are quite important in point number D, which will make the more accurate choice for this statement. Although in point B there are some informations like updating a specific part of the LLM, this was quite closer. But if you compare point B and point D is more closer to the statement what we are looking in the question. So that's why we will mark point B as a wrong option and we will go for point number D. How does T-Few fine-tuning improves the efficiency of fine-tuning LLMs compared to traditional models? And here are the options. T-View fine-tuning achieves efficiency by selectively updating a small portion of transformer layer in the LLM, which leads to faster training times and the lower computational cost compared to traditional methods that update all the layers, right? So now let's consider all the statements what are given. The first statement is it utilizes a completely different neural network architectures compared to the transformer. Now TFU leverages the existing transformer architecture, but it optimizes the training process, right? It does not focus on different neural architecture. So that's why this statement is not correct. Now the option number B is it focuses on updating the weights of specific words in LLM vocabulary, right? Word weight. So here the focus is on word weight sentence. While specific weights might be adjusted, TFU focuses on layers, not on the individual words, right? So that's why this statement also is not correct. Now the option number C is it updates all the layers in LLM but with a lower learning rate. As we already discussed, TFU means a specific thing, right? It is not focused on all the layer. So this one also is not correct. And also here the more focus is on low learning rate. While learning rate can affect the training time, TFU's primary advantages lie in updating few layers, not just adjusting the learning layer for all layers, right? So that's why this statement is also not correct. Then the remaining statement with us is point number D. But let's try to understand first what is in the point number D. It updates only a small subset of transformer layer in LLM, reducing training time and the cost. So that is what is the definition of TFU, right? So that's why the TFU fine tuning for this statement D is the more accurate and it clearly provide the informations. So the passage mentions TFU fine tuning being used with the transformer layer, employing its work within the existing transformer architecture, right? And also it reduces the time and cost. So this aligns the concept of updating only a small subset of layers which requires less computational resources. I hope this will give you a clear understanding how we can choose which option is correct out of this four. Within a dedicated AI cluster for OCI Generative AI, how many base model endpoints and custom endpoints can be hosted? So here some of the key points are it is talking about dedicated AI cluster, and here how many base model endpoints and custom model endpoints, right, that can be hosted. So now let's read each of these statements, all the four options. A dedicated AI cluster in OCI Generative AI allows for hosting one base model endpoint and a maximum of n custom model endpoints, that is 50 custom model endpoints, providing the flexibilities for deploying a base model alongside several fine-tuned custom models, right? Now let's read each of this statement. So the first statement is the cluster can host only one base model endpoint and no custom endpoint. So this statement is not correct. Here the focus is on no custom models. The passage allows for hosting custom models just with a limit, and the limit is 50. So this statement is not correct. Now we will see the option number B. The cluster can host an unlimited number of base model endpoints and one custom model endpoints. Here the focus is on unlimited base model. The passage specifies one base model endpoint per cluster. We do not have unlimited base model. So this statement also is not correct. And also it is focusing on one custom model endpoint, although it can allow n number of custom model endpoints. So now this statement also is not correct. 1 is gone, B is gone. Now let's go towards C. The cluster can host one base model endpoint and an unlimited number of custom model endpoints, right? So here the focus is on unlimited custom models, which is also not correct. The passage restricts the number of custom model with up to n, and n will be the value of 50, right? So this point is quite closer, so we can just think of this one, and we can sometimes get confused. Okay, this one is quite closer, so this we can think of keeping in our part to decide this one is correct or not. So now let's go to the another one. The cluster can host one base model endpoint and up to a specific number of custom model endpoint. So this statement is completely correct because it is allowing only the limited number of custom model endpoints, that is 50. So with that thing, the point number D is quite accurate. So this passage mentioned a dedicated AI cluster with one model base point and up to n fine tune custom endpoints, which means it is a limitation on customer model, but it will allow only a single base model. So this statement is completely correct. So the option number D is right. What does the ranker do in a text generation system? So here it is looking for the ranker's observation. So here are the points A, B and C. Let's pause for a while and we will discuss. So what is rancor? Rancor plays a crucial role in ensuring the quality and relevance of text generated by the system. It acts as a filter, selecting the best information from the vast amount retrieved by the retriever to be used in the final output. So what are the different functionality of the rankers? In the text generation system, the ranker acts as a quality control and selection mechanism. It does not directly interact with the user or generate the text itself. And what about the retrieval's rules? So the retriever is responsible for fetching the relevant information or text passages based on the user's query. So what will be the ranker's task then? So once the retriever gathers the potential information, the rankers take over. It evaluates the retrieved information considering factors like relevance, coherence and factuality. It then prioritizes the information, selecting the most suitable pieces to be used for final text generation. Okay, so I hope now we understand what is ranker, what is the task of ranker, and what is the main functionality for rankers. Now let's discuss about each of this point. So first option is it interacts with the user to understand the query better. User interaction. So here the focus is more on the user interaction. So this is not the correct option. This is typically handled by a separate user interface component. This is not the role of rankers. Then option number 2 is it generates the final text based on the user's query. As we discussed, it is not bothered with respect to the generating any text, but it will come as an intermediator, right? So this option also is not correct. The actual text generation is often done by a separate module that utilizes the prioritized information from the ranker. So this also is not the correct choice. Then option number C. It evaluates and prioritizes the information retrieved by the retriever. So this information is the more accurate explanation of the ranker's role in text generation option. That's why this statement is correct and the option number C is correct. But before still going with option number C, let's see the point number D. It sources information from databases to use in the text generation. So this is more focusing on information sourcing. While the retrieved information might come from databases, the ranker focuses on evaluating and prioritizing, not actively sourcing the information itself. So that's why, although this information also looks quite closer, but out of point C and point D, point number C is more accurate and the correct option is point number C. Evaluation and prioritization information retrieved by the retriever. What role chain of thought plays in reasoning tasks for LLMs? Here are the options. Now let's discuss what is the correct answer and why other answers are not correct. The option number B is correct. It provides the LLM with a structured approach to break down complex problem into smaller and more manageable steps. Now let's try to evaluate this. Chain of thought refers to the technique where LLM explicitly explains its reasoning process step by step. A structured approach helps the LLM to break down the complex problem into a smaller, easier to understand subproblem. This allows LLM to reason through the problem in a more logical and transparent way. Now consider another sentences which are given here. Option number A, replace algorithm. Chain of thought supplements reasoning. It does not replace any traditional machine learning algorithms which are entirely. That's why this statement is not correct. Control output. Chain of thought does not directly control the final output, but it can improve the quality and explainability of the output by making the reasoning process clear. So that's why this option is also not clear. External data. While chain of thought might involve internal data for reasoning, it does not necessarily require accessing external data sources during this process. So that's why this option also makes it incorrect. What do embeddings in LLM represent? Here are the options. In LLMs, what do the embeddings captures about the data they are trained on? Option 1 is grammatical structure. While LLMs can learn about grammar to some extent, embeddings don't directly represent the grammatical structure of sentence. They focus on capturing meaning. So that's why this statement is not right. The second is semantic content. This is the most accurate answer. Embedding in LLMs are high-dimensional vectors that encode the semantic contents of the words, phrases, or even entire sentences. These vectors represent the meaning and relationship between concepts within the data. Similar words or concepts will have similar vector representation in high-dimensional space. So this option is correct. Now still we will have two more options to verify. The third is word and pixel frequency. While word frequency can be a factor in training LLMs, embeddings go beyond simple frequency. They capture deeper semantic relationship between these words. So this option is not correct. Font and color size. Embeddings are not used to represent visual properties like font, color or size. They focus on capturing the meaning of textual data. So this statement also is not correct. Imagine a bookshelf where each book is a word or concept. Embeddings are like unique addresses assigned to each book, but these addresses are not random. Books with similar content will be placed on nearby shelves in this high dimensional space. This allows the LLM to understand the relationship between words and concepts, which is crucial for tasks like generating text, translating languages, and answering the questions. Which is the key characteristics of LLMs without RAG? And here are the options. Let's discuss each of these options. The first option is they use vector databases exclusively to produce the answers. So here the focus is on what? Vector databases. While LLM can benefit from retrieval techniques like RAG that utilizes vector database, they don't exclusively rely on them for the answer generation. Without RAG, LLMs can still generate response based on their internal knowledge, right? So this option is not correct choice. Then the second option is they rely on internal knowledge learned during the pre-training on large text corpus. This is the core strength of LLMs without RAG, internal knowledge, right? So during pre-training on massive amount of text data, they learn complex relationships between words, concept and pattern in the language. This internal knowledge allows them to generate text, translate languages, write different kinds of creative content and answer questions based on their understanding of the word as presented in the training data. So this option is quite closer and it is the correct choice. But still, let's discuss about point number C and D. So the option C is they cannot generate responses without fine tuning. So here the focus is on fine tuning. While fine tuning can further enhance the performance of LLMs on specific tasks, some LLMs can still generate reasonable outputs without it rely solely on their pre-trained knowledge. So this option also is not right choice. Then the option number D is they always use an external database for generating their responses. So here the focus is on external database. LLM without RAG don't necessarily require an external database to generate the responses. They utilizes the knowledge they acquire during pre-training. So that's why this option is also not correct, because here the main characteristics of LLMs is focusing on without RAG generation. So that's why while considering the statement what is asked in the question, the more suitable choice is the option number B. It is focusing on the internal knowledge which they have learned during the pre-training, right? So that's why the option number B is the correct choice. When does a chain typically interact with memory in a run within the LangChain framework? And here are the options. The correct answer is after user input but before chain execution, and again after core logic but before output. Here's why this is typical interaction between a chain and memory in LangChain. Before user input, there is no user interaction yet, so no need for memory at this stage. After user input and before chain execution, this is when the chain reads from memory to access relevant information that might be needed for processing the user input. This could include past interactions, context variables, or other data stored in the memory system. Chain execution performs its core logic based on the user input and potentially the retrieved information from the memory. And after core logic, that is before output, here's the chain might want to write the result of its processing or any relevant information back to the memory. This could be updated context, intermediate results, or data that might be useful for subsequent chains in the LangChain workflow. And the final is output generation. Finally, the chain utilizes the process data and potentially the updated memory to generate the final output for the user. So essentially, LangChain memory acts as a bridge between user input, chain processing, and final output. It allows the chain to access past information and store relevant data for contextual understanding and potential use by subsequent chain in a LangChain application. If you know someone interested in exploring generative AI, share this video with them. The more the merrier on this journey. Thank you for watching and best of luck in your generative AI certification journey.